The Republic XF-84H was an attempt to push propeller aircraft into the jet age, but it was so loud it made people sick. The men had a name for it, the Thunderscreech. At Edwards Air Force Base in 1955, a test pilot climbs down from an experimental fighter still ticking with heat. His name is Lynn Hendricks, and he flies dangerous aircraft for a living. Prototypes, unfinished machines, airplanes other men have already refused. Hendricks stomps across the tarmac to find Republic Aviation's chief engineer waiting for a report. What he says next will follow the aircraft for the rest of its life. Quote, "You aren't big enough, and there aren't enough of you to get me in that thing again." In the early 1950s, the jet age still felt unfinished, as if something were missing. Jets were fast, glamorous, and clearly the future, but they also had a vicious flaw. When a pilot shoved the throttle forward, the engine did not answer instantly. It took time to spool up. On a long runway, that delay was dangerous. On an aircraft carrier, it could be fatal. A pilot coming in low over the deck, missing the wires, and asking for power right now could not afford to wait for a lazy turbojet to wake up. That problem obsessed naval planners. They wanted the speed of a jet, but also the lower landing speeds, better fuel economy, and quicker low-speed response of a propeller aircraft. In other words, they wanted the future without giving up the one thing the past still did better. That weakness kept one door open for the propeller aircraft, even as the jet age was clearly taking over. The goal was to take the best of both and force them into one machine. That path led to Republic Aviation. Republic already had experience with the swept-wing F-84 family, and the new aircraft would be built on that lineage. But this specific warplane was not going to be a routine derivative. It was conceived as a high-speed turboprop experiment, built to test whether a propeller aircraft could be pushed far enough to stay relevant in the jet era. This was an ambitious joint Air Force and Navy effort to explore whether a turboprop could deliver a combination that jets still struggled to provide. The program had a formal designation buried inside its paperwork, Project 3347. To the wider Air Force, the prototypes were briefly listed under a different label. They were first earmarked as XF-106, the designation the Convair F-106 Delta Dart would later inherit and make famous. Only after a redesignation did the aircraft settle into the XF-84H identifier, anchoring it publicly to the F-84 family. The Air Force formalized its contract in December 1952, ordering 2 prototypes. The Navy had initially planned to join the program with a third airframe of its own, part of its parallel pursuit of a catapultless carrier fighter. Republic's answer was to build a fighter around a turboprop powerful enough to drag a propeller aircraft into jet territory. The engine they chose was the Allison XT-40A1. It effectively combined 2 turbine power sections via a common gearbox, sending the combined power to a single shaft. Depending on the source and rating, the system was credited with roughly 5,300 to 5,850 shaft horsepower, plus some residual jet thrust. That was an enormous amount of power for a single-engine aircraft, and it created the central problem of the whole program. How do you convert that power into speed without tearing the airplane apart in the process? Most T-40 installations use contra-rotating propellers to absorb all that power more evenly. The XF-84H did not. Republic drove a single 3-blade propeller at the nose, 12 feet in diameter. The propeller was huge. At full operating speed, about 2,100 revolutions per minute, or RPM, the outer sections of those blades were moving faster than sound. Modern summaries put the propeller tip speed at roughly Mach 1.18. The arrangement behind that single propeller was intricate. 2 T-38 power sections sat mid-fuselage behind the cockpit, spinning at close to 40,000 RPM. 2 drive shafts, roughly 18 feet long, ran along either side of the pilot and converged on a reduction gearbox immediately aft of the propeller. That gearbox carried the burden of turning extreme rotational speed into the propeller's steady 2100 RPM. The blades themselves were steel, square-tipped, supplied by Aero products. Thrust was modulated entirely through pitch changes. The propellers spun at constant speed from startup to shutdown, supersonic tips and all. That was the airplane's central gamble. A turboprop was supposed to give the military some of what it still liked about propeller aircraft: better efficiency, lower landing speeds, and quicker thrust response than the early jets then in service. But Republic was not building a conventional turboprop fighter. To get the speed they wanted, they had to push the propeller into a regime that propellers were never comfortable in. Once the blade tips went transonic and supersonic, the aircraft was no longer just fighting drag and engine limits. It was fighting compressibility itself. The rest of the airplane had to be shaped around that choice. Despite emerging from the F-84 line, the XF-84H needed some serious modifications. It required a T-tail and a prominent dorsal fin behind the cockpit, because the airflow and torque from that propeller changed the way the entire aircraft behaved. Republic also had to fight torque through the airframe itself. The left leading-edge air intake was mounted 12 inches farther forward than the right. The flaps were given differential operation. A fixed dorsal yaw vane was added to counteract P-factor. Every one of those modifications existed to tame a single propeller. The propulsion system was driving the layout. It was deciding what the airframe had to become. There were other signs of how radical the project had become. The XF-84H was the only turboprop ever fitted with an afterburner, though that afterburner was used only on the test stand and never in flight. It was also the first aircraft to carry a ram air turbine for emergency hydraulic and electrical power. Even before the airplane proved anything, the design was already accumulating unusual solutions to unusual stresses. On paper, though, the machine still had a seductive logic. If the engine held together, if the gearbox behaved, if the propeller could keep delivering thrust efficiently at high speed, the XF-84H might offer something no ordinary prop fighter and no early jet could match. That possibility kept the program alive. But before the aircraft ever built its reputation on the ground or in the air, the warning signs were already appearing in the aerodynamic data. The trouble showed up before the airplane had any chance to become infamous. In 1953, NACA began testing models of the XF-84H configuration, and the results were bad enough to put the whole concept under suspicion before the first prototype ever flew. With the propeller operating, the aircraft showed destabilizing tendencies that spread across the handling of the whole machine. One report found longitudinal instability at moderate angles of attack. At higher angles, the ailerons and rudder became seriously deficient. The problem was that the propeller, the very thing meant to make the airplane exceptional, was disturbing the airflow in ways the rest of the aircraft struggled to account for. In other words, the control surfaces were not designed to handle the disturbances caused by a supersonic propeller. This was a critical issue. A fighter can tolerate power. It can tolerate torque. It can tolerate difficult handling within limits. But once the propulsion system starts poisoning the effectiveness of the control surfaces themselves, the entire aircraft begins to turn against its pilot. That is what NACA was seeing. The propeller was altering the airplane's behavior. Engineers tried to fix it. They tested modifications. They revised the configuration. The tail arrangement was altered. The rudder area was increased, and other changes were explored to regain control authority and stabilize the airplane. A later NACA memorandum on the revised layout showed some improvement, but even that was not a clean victory. The better configuration was judged satisfactory, only within a limited flight envelope. The deeper problem remained. One NACA conclusion was especially revealing. None of the configurations tested up to that point provided satisfactory behavior for all normal flight conditions. That's a devastating sentence to have hanging over an aircraft before a full flight testing even begins. The wind tunnel was only surfacing the aerodynamic face of a larger problem. The Allison T-40 had a reputation that preceded the Thunderscreech. Testing of the XT-40 began in 1948, and its reduction gearbox had to be redesigned almost immediately, because tooth-meshing frequencies produced destructive vibration. The same engine family powered the Douglas XA-2D Skyshark and the North American A-2J Super Savage, two other troubled post-war aircraft. On December 14, 1950, the first XA-2D prototype crashed, and its pilot was killed. A failed T-38 power section had gone unrecognized, while the surviving section burned itself out, trying to compensate. That accident was 5 years old by the time the XF-84H flew, but the pattern it established followed the engine wherever it went. Republic had also cycled through several exotic propeller blade configurations before committing to the final Aero Products design. It meant the XF-84H was entering the next stage of its life, with its central weakness already documented. The men who would eventually fly it were stepping into a flawed machine, possibly a death trap. The military wanted a high-speed aircraft that could preserve the low-speed virtues of the propeller. What the data was showing instead was that forcing a propeller into that speed came with consequences that pierced into the very blueprints of the aircraft's design. By the time the prototype moved toward flight testing, the XF-84H was already carrying two identities at once. On paper, it was still the answer to a real military requirement. In the wind tunnel, it was becoming evident that the answer might be too unstable to use. The first flight would decide which of those truths mattered more. The first flight came in late July 1955. Even that date comes with a small warning. Some sources place it on July 22nd. A later archival reconstruction argues for July 21st. The XF-84H did not vindicate its designers. It flew and began confirming the fears that had already surfaced in testing. The airplane was difficult from the start. There were severe vibrations, control problems, and engine-related issues. The combination of massive turboprop power, disturbed airflow, and a mechanically demanding drive system had produced a machine that was hard to control and hard to trust. The test record makes that brutally clear. Between July 1955 and October 1956, the two XF-84H prototypes flew only 12 times. 11 of those flights ended in emergency landings. The physical journey of the prototypes before the first flight hinted at the strangeness to come. Both XF-84Hs were built at Republic's plant in Farmingdale, Long Island, then disassembled and shipped by rail across the country to Edwards. Even basic test preparation was demanding. The propeller drive system required about 30 minutes of warm-up before each flight could begin, an unusual preamble that ate into every test window. The two airframes carried serials 51-17059 and 50-17060. The first flew 8 times, the second only 4. No USAF test pilot ever flew the aircraft. Both airmen who took it up were Republic employees. Hank Beard flew 11 of the 12 sorties. Lynn Hendricks flew the remaining one, then delivered his verdict. The Thunderscreech was not having an occasional bad day. Emergency procedure had effectively become its normal operating condition. Part of the disappointment was performance. The whole point of the project had been to create a propeller-driven aircraft that could reach deep into jet territory while preserving the advantages jets lacked. But the airplane never came close to becoming that clean breakthrough. Republic engineers were aiming for a maximum rate of 520 miles per hour, while reports from the prototypes themselves do not appear to have exceeded roughly 450 miles per hour in actual testing. The original eye-catching figure pitch of around 670 miles per hour was shelved as fiction. That gap between promise and result was fatal. If the XF-84H had delivered astonishing speed, some of its uglier traits might have bought themselves more time. Experimental aircraft are allowed to be temperamental if they are clearly opening a new frontier. The Republic machine was doing the opposite. It was combining instability, vibration, and mechanical headaches with performance that no longer looked worth the price. And yet, the flights continued, because the military still needed an answer. The Navy's original problem had not disappeared. Carrier aviation still wanted quick power response and safer low-speed handling than early jets offered. The XF-84H was still technically one possible answer, but each flight was narrowing that possibility. Every emergency landing made the aircraft look less like a difficult prototype and more like a concept failing its most important test, just flying safely. What happened in the air was already bad enough. What made the airplane infamous was what happened whenever it started on the ground. The aircraft's propeller was turning at about 2100 RPM, and because the blades were so large, their tips were moving at roughly Mach 1.18. That meant the XF-84H was not just producing engine noise or propeller noise in the ordinary sense. The outer sections of the blades were generating shockwaves. With 3 blades rotating at that speed, the aircraft was creating roughly 105 blade passage shock events per second. No one on the base needed a technical explanation to know something was wrong. They could feel it. A conventional propeller noise cycles with the engine setting. The Thunderscreech did not. Because the propeller turned at constant speed, the outer 24 to 30 inches of each blade traveled faster than sound from the moment the engine started, right through idle, right up to shutdown. The shock environment was continuous. Contemporary accounts describe a visible standing wave radiating laterally from the blades for hundreds of yards, a sonic disturbance that held as long as the engine ran. At Edwards, the noise eventually forced a change in procedure. Engine test runs had to be pushed to a remote section of the base because the sound spilled across the main complex and drowned out air traffic control radios. Controllers could not hear incoming traffic while the XF-84H was warming up. A single experimental aircraft was interfering with the operation of the airfield around it. The safest way to state it is also the most accurate. The XF-84H was very likely the loudest aircraft ever flown, but no scientific measurements were taken, so the title is unofficial. Guinness uses exactly that cautious framing. Even with the caveat, the stories surrounding the airplane are extreme enough to stand on their own. This was not normal military aircraft noise, pushed a little too far. It was something crews had to brace for. At Edwards, ground runs became ordeals. According to the Smithsonian's account, people in the control tower worried that the aircraft would shatter windows. Radio shelves were covered with blankets. Personnel sheltered under desks during engine runs. The XF-84H was not merely loud enough to irritate people around it. It was loud enough to make people physically sick. Guinness reports that men caught in the prop wash vomited or fainted. Smithsonian preserves the same pattern from first-hand recollection. The aircraft brought grown men to their knees. The most famous story involves a crew chief in a nearby C-47 during a 30-minute run-up. He did not know what was happening outside. When they found him, he was on the floor, incapacitated and flailing. He recovered, but the incident stuck. The story hardened into more sensational versions, but the best supported one is already bad enough. The airplane's shock and noise environment could physically overwhelm people who were nowhere near the cockpit. Test pilot Hank Beard gave the clearest description of what that meant in practice. Anyone caught in the plane of the propeller shockwaves, he said, could be knocked down. Pilots hated flying it because of the instability, the danger, but above all, the insufferable noise. And this last curse extended to the crews and personnel on the tarmac. No one was safe from the loudest warplane in the world. There were even reports of complaints from as far as 25 miles away. The aircraft's notoriety did not come from post-war exaggeration. It came from the fact that the airplane's basic operating condition was hostile to human beings. Its engine could be maintained. Its propeller could be spun. Its systems could be tested. But every time that happened, the whole surrounding environment turned violent. By now, the program had a problem no amount of engineering finesse could easily solve. The The Navy wanted an aircraft safer around carrier operations than an early jet. Republic had built a machine that forced pilots to emergency land and crews to puke on the tarmac. And command expected pilots to keep flying it. By the time the noise had made the XF-84H infamous on the ground, pilots dreaded even the mention of the thing. A difficult airplane can still earn respect if it's predictable. The Thunderscreech was not. For the men flying it, that meant every sortie began with two questions hanging over the cockpit. Would the engine and gearbox behave? And if they did, would the airplane itself? After one of the flights, test pilot Lynn Hendricks reportedly told Republic's chief engineer, quote, "You aren't big enough, and there aren't enough of you to get me in that thing again." Underneath Hendricks's defiance, the complaint was technical. He reported that the airplane refused to exceed roughly 450 knots indicated, because at that speed, it began snaking along its longitudinal axis, shedding the stability Republic most needed it to keep. The program had been sold on its ability to push propeller flight into jet-class speed. The aircraft was now telling its pilots that it lost its grip precisely where that promise was supposed to pay out. Beard's experience only confirmed it. The physical punishment of long drive shafts running alongside the pilot, a supersonic propeller feet from his face, and the harmonic environment those components imposed on the airframe meant every flight was a fight to keep the aircraft inside boundaries it kept trying to escape. Experimental pilots were paid to climb into dangerous aircraft. Refusing one so bluntly meant the machine had crossed a line. It had become something a professional test pilot judged not worth the risk. Hank Beard, the other pilot most closely associated with the airplane, left the same impression from a different angle. He remembered the physical violence of the airplane on the ground, the effect of the shockwaves on nearby crews, and the way the aircraft's whole presence distorted normal procedure around it. The numbers behind the flight program explain why pilot confidence never recovered. The two prototypes made only 12 flights. 11 ended in emergency landings. That kind of ratio destroys any illusion that the aircraft is slowly maturing into usefulness. Its projected performance had helped justify the whole concept. If a turboprop fighter could get deep into jet-class speed while preserving better low-speed behavior, maybe the pain would be worth it. But the prototypes never delivered the kind of achieved speed that could overpower the rest of the argument. The aircraft remained unusable, mechanically difficult, and exhausting to operate, while its real-world performance looked increasingly ordinary beside the promise that had launched it. It was giving airmen extraordinary mechanical and aerodynamic punishment in exchange for results that no longer justified the hazard. By then, the verdict inside the program was already taking shape. All that remained was for the military to admit it. By the end of the test program, there was no real case left for saving the XF-84H. A strange aircraft can survive if it offers something decisive in return. The Thunderscreech did not. The total flight time is best stated cautiously as less than 10 hours. The airplane consumed years of design effort and barely managed a few hours in the sky before the program collapsed. The engine arrangement was too demanding. The propeller imposed too much on the airframe. NACA had already found, before full flight testing, that propeller operation was generally destabilizing, that the aircraft suffered longitudinal instability at moderate angles of attack, and that there were serious aileron and rudder deficiencies at higher angles. Engineers had tried to revise the configuration, but even the improved version was only judged satisfactory within a limited envelope. Once those aerodynamic penalties met the vibration, control trouble, and emergency recoveries of the real flight program, the military was looking at a concept that kept failing in exactly the way as its own data had warned it might. The aircraft's performance could not rescue it. The spectacular projected figures attached to the design were not replicated in testing. And while Republic was fighting the aircraft, time was fighting it too. The whole reason the program existed was that early jets still had weaknesses, especially in throttle response and low-speed handling around carrier operations, but those weaknesses were not permanent. Jet technology was improving fast. That meant the XF-84H was not just trying to justify itself against its own flaws, it was trying to justify itself against a future that was arriving without it. Even if Republic had managed to tame some of the aircraft's worst habits, it still would have been selling a brutally complicated compromise in an era increasingly willing to leave propeller fighters behind. So the program ended, and the airplane passed into a different kind of life. The program's death came in stages. In April 1956, plans to integrate the more powerful Allison T-54 turboprop into the airframe were shelved, along with parallel development work on Curtiss and Hamilton standard supersonic propeller designs. Resources were redirected back into finishing the flight tests with what was already built. By September 1956, the Air Force canceled the Thunderscreech entirely. The two prototypes went their separate ways. Airframe 51-17060 was scrapped. Its Allison XT-40 engine was reportedly pulled and reused for Douglas XA-2D Skyshark development. The survivor, 51-17059, escaped the smelter and ended up at Meadows Field Airport in Bakersfield, California, where it was mounted on a display boom outside the terminal. An electric motor kept its propeller turning for passing drivers. It stayed there until 1992. Ohio Air National Guard volunteers from the 178th Fighter Wing pulled it down and put roughly 3,000 hours into its restoration. The surviving first prototype eventually went to the National Museum of the U.S. Air Force, where it remains on display. Silent, it looks almost manageable. That's the final irony of the XF-84H. What survives now is the aircraft's shape, but not its operational reality. Visitors can study the nose, the propeller, the tail, the lines inherited from the F-84 family, but none of that conveys what made the airplane unforgettable to the men around it. They cannot hear the shockwaves rolling off the propeller tips.